This is part 2 of our video series about how to use a hydrogen fuel cell to produce electricity without emitting greenhouse gases. Please make sure you've watched part 1 before continuing here with part 2. But of course, we don't use hydrogen fuel cells very widely right now. And the problem, it turns out, is that it's very difficult to find ways to generate that hydrogen gas economically and in a way that does not use more energy than it consumes. Let me explain. So we see here that synthesizing water is exothermic. It releases energy. That means, though, that the opposite, decomposing water, getting hydrogen gas from water, which is really the best way for us to generate hydrogen gas. There may be some other ways. For example, we could start with ammonia and try and make hydrogen gas, but right now, the way that makes the most sense is to get that hydrogen gas from water because water is so abundant. But the problem is, if I reverse the reaction, decomposing water is endothermic. So in other words, to use water to get some hydrogen gas that we could then use as fuel for the fuel cell, I would need to put in energy. And that doesn't really make sense. That's like paying $20 to get $20 back, if you follow me, right? Like I don't want to have to use energy to get a fuel that I would then use to make energy. So is there some way that we can generate the hydrogen gas without having to spend so much energy, right? Like that seems like we don't really want to have to use energy to get energy. Now, the reason that we would have to use energy to get hydrogen gas out is because we would need an electrolytic cell to generate hydrogen gas from water, right? This is kind of what we talked about in the last video where we looked at an electrolytic cell. So here is another way to phrase this kind of dilemma that we're in, right? We can use hydrogen gas as a fuel to power a voltaic cell that can get us electricity. The problem is we need some way to get the hydrogen gas from water, which, requires energy. Here's the opposite simulation, right? Last time we looked at a voltaic cell. Now let's look at an electrolytic cell. We were looking at a voltaic cell that was allowing water to be created. Now we're going to look at an electrolytic cell that is decomposing water. So this is essentially the opposite process, right? The reaction that's occurring now is that water is splitting into hydrogen gas and oxygen gas. And we can see that batteries need to be hooked up in order for this to happen. So power in, right? Electrical energy in. And if I want to figure out which side of the reduction is occurring on and which side oxidation is occurring on, I'm going to want to, again, think about the oxidation states of my two elements. So if I have H2O, in H2O, I'm starting off with hydrogen with an oxidation state of +1, and I am ending with hydrogen with an oxidation state of 0 because the hydrogen gas is ending up by itself. So that means the hydrogen is being reduced. Notice how that's the opposite of what was happening in the hydrogen fuel cell. The hydrogen was being oxidized in the fuel cell. Over here, where oxygen is involved, I notice that oxygen starts off with a oxidation state of -2 because it's in a compound with hydrogen, and the only oxidation state that oxygen can have according to the periodic table is -2. And it is becoming, after the reaction, an oxidation state of 0. So that means that oxygen is getting more positive. So oxygen is being oxidized. It is losing 2 electrons to go from being -2 to 0 as its oxidation state. So in this particular cell, the cathode is where the hydrogen is and the anode is where the oxygen is. And this is essentially the opposite process of what was happening in a hydrogen fuel cell. This is what we need to get to happen as scientists on Earth. We need to be able to do this reaction in some way without needing to use some of our precious power. So one idea that scientists have that's really exciting is called photoelectrolysis. So instead of using electricity where we have generated the electricity from a battery or from some other source of electricity that's precious to us, we could actually use the sun's energy. We could use a photovoltaic cell. Photovoltaic, photo as a prefix means sun. So if we're using a photovoltaic cell, we're saying that we could maybe use energy from the sun to get this hydrogen gas so that we can store and ship the hydrogen gas around the world. It would be a better source of clean energy than things like solar or wind, because as long as you have the hydrogen gas stored, you can continue using it as a fuel. Whereas if you were directly using the sunlight, you could only charge your batteries when the sun was up. And if you were using wind, you can only charge your batteries when the wind is blowing. So hydrogen gas might be easier to store and transmit than some of our other renewable options. Let's check back in on our learning goals. Hopefully you feel like you have a better understanding about why scientists might be really excited to be designing hydrogen fuel cells and processes to generate hydrogen gas that can be used in these fuel cells. This is one really promising source of energy that we could use without releasing more carbon dioxide or other greenhouse gases into the atmosphere. Nice job today.